You are watching the MotionWorks IEC hardware configuration video tutorial series. This video gives you some hands-on training on the basic concepts of hardware configuration. Hi, I'm Matt Pelletier. Here's a quick preview. The hardware configuration contains the settings for each part of the control system, such as network protocols, I/O cards, and servo axes. This data exists both offline within the project and online within the controller. When you connect your project to the controller, the offline and online data is compared. If not identical, you can choose to work with offline or online. To make the selection permanent, save while connected online to the controller. Now let's go through this in more detail. Before we get too deep into it here, let me touch on a few prerequisites. We do assume you know a little bit about servos, so check out our Servo Basics video if you haven't already. We'll be navigating in the web UI from time to time, so you need to know how to use it. Therefore, I'm assuming you've already completed that training. And finally, to follow along in this tutorial, you need connection to one of our MP3300 IEC and Sigma 7 demo units, as I have here. If you would like remote access to one of these demos, please request by email to training@yaskawa.com. You can see how this works in the remote connection e-learning video. Hardware configuration controls the settings of the controller and the devices that connect to it. These are settings such as the IP address, I/O card settings, and the settings of the network communication protocols. So why don't we dive right in and look at the offline hardware configuration of a new project. Please follow along with me in MotionWorks IEC version 3 Pro. I am using version 3.3.099, and we'll go to File and make a new project and choose the template for the controller we have, which is the MP3300 IEC template. Click OK there. And rather than leave this untitled, let's save it right away. File, Save As. You can save it right in the projects folder. And let's name it project_HC and save. The hardware configuration is this button, which I've moved this toolbar up here to save space. Click that to launch the hardware configuration. For now, we're going to stay offline, so please do not click the connect button. And if you did, just close this and open again. And now let's quickly overview what we see here. At the top level, you have the project. You can click on each of these. Resource is the IEC 61131 term for the controller. The controller type and variant can be changed. This is useful when you're trying to convert a project from one type of controller to another. And you got tabs here for status and system and alarms. When you're online, you'll see that information. In the tree now, the next level under the controller is Mechatrolink 3. This has to do with all of the servo axes and possibly remote I/O that's connected over the Mechatrolink network. And we'll be working with these settings in the rest of this training course. Moving down here in the tree, groups are set up for PLC Open Part 4 and multi-axis coordinated motion. TCP/IP settings are really the same settings that you can see in the web UI when we looked under Setup, Ethernet Config. And Ethernet IP and Modbus TCP allow you to configure the controller as a slave here in the top section and as a master in the bottom section. So how about we set up this project for the IP address of the controller that you're connected to. And I'm connected to 192.168.15.71. You can go here to TCP/IP settings and make that adjustment. When you save that, you can see it does not affect the connection IP address, but go ahead and close hardware configuration, launch it again, and you see it does read that in when you launch the hardware configuration. Now, when we're offline like this, you can add devices that you expect to have in the system when you go online. At the controller level, the resource level, just right-click on it, add device, and you see all of the expansion bases, the 8-slot, 3-slot, or 1-slot base. Let's choose, for example, the 3-slot base, and click Finish. And that makes the option base appear as part of the controller. Click on that. And now right-click one of the slots to add a device to that slot, such as, pretty common one is the LIO01 digital input card. So click Finish. The task rate just means the rate at which the I/O status communicates with the ladder program. The default of fast is fine, so we'll add. Now you click on the LIO01 card, and the LIO01 card contains an encoder input, which is reported to the controller as logical axis 65. And in the case that you would truly connect an encoder to this card, you can see here the settings for the unit and the encoder resolution, etc. Okay, now let's jump up to Mechatrolink 3. We'll work with the network settings in the next video, but for now let's add a servo to the Mechatrolink network with, as before, right-click, Add Device, and let's choose the SGD7W dual axis amplifier, which is what we do have on the demo. For node number, you might assume it's node number 1, but when you add this, you see that the minimum is 3. Okay, let's change that to a 3 and click Add. This is a dual axis amplifier, and therefore you see it added both axis 3 and axis 4. And when you click on each of these axes, it's pretty evident that there are a lot of settings. And one of the most important is the configuration tab, because this is where you establish the units of motion and load type and axis name. In the next video, you will set the units and the most essential of these parameters from the other tabs. Feel free to look around, but this is all we'll do for now. So let's save what we've done under File Save. And I know you might be anxious to hit the connect button, but before we go online, I would like us to get the controller running with an archive that I have prepared. This is part of your class materials download. And you know that the archive can be sent through the web UI under Setup Archive, but you can also send it through the hardware configuration itself under the online menu, Controller Configuration Utilities, and you do have to be offline in order to use this. So there are different options that you can use this for, but we are going to take the fourth one down, Send Project Archive to Controller, and then Reboot. Click Execute. Now you need to navigate to the archive in the Class Materials folder, and it's called Archive Hardware Config. And we'll open that. And that action sends it down to the controller, and they prompt us for the reboot. Let's click Yes. And the controller is finishing its reboot cycle here, and now it's ready with the new archive. The next basic concept of the hardware configuration is that this data is stored offline and online. We have been working so far just offline. If you haven't done so, please save the configuration, and then let's go ahead and close it. Just to verify that your project is not labeled untitled, be sure it does have a name. And here in the project tree, you can even see at the top level the complete path on your hard drive where that project is located. Just as a teaching point now, let's go and locate that file in Windows Explorer. It is C, Users, Public, this is Windows 7 by the way, Public Documents, MotionWorks IEC3, Projects. That's the default, and I have a subfolder. And here you see the offline project. A project consists of an MWT file and the accompanying project folder that has all of the project data. You don't ever want to change any of these files directly, but if you open up in here, you can see there's a folder called C, and then configuration, and R. You can just keep going deeper into this, and eventually get to config files. And these are the files that are saved when you click the Save button in MotionWorks IEC Hardware Configuration. They are XML files. And this is basically the offline configuration stored in your PC. So what about the online configuration? Many of these same files are stored on the controller. And you can see them in the web UI. Let's go to the web UI and log in. Under Setup, you can choose Configuration Sets. And you see there are 1, 2, 3 sets of XML files that are the online configuration for the controller. Starting at the bottom, the configuration files in Startup are used by the controller under normal circumstances, and you see the selection indicator next to it. The files in Disco are the devices discovered by the controller at PowerUp, each with a default configuration. These files are refreshed at every reboot as long as the config dip switch remains on. And notice there's no selection indicator for Disco. That's because this configuration cannot be used directly. It's only used if there is no startup configuration, such as when the controller is at factory default. And if there's no startup configuration, then when you connect, this discovery configuration can be read into the project using MotionWorks IEC, or you can save it back to the controller as the startup configuration. This is a lot easier than manually adding each device like we did previously. Again, this option is available at factory default or if you were to delete the startup. We have a separate video on resetting to default. If a particular XML file does not exist in the startup configuration, such as this www.xml file is one example, and it doesn't exist in the Disco configuration, then the file in the default configuration is used by the controller when it boots up. These are the permanent factory default files that exist on the controller. You can force the controller to use only the files in the default configuration by rebooting with the init switch on. This can be useful if the configuration has somehow been corrupted. You can then just reboot the controller to default configuration and try to troubleshoot the problem. Let's go back now to MotionWorks IEC and start hardware configuration again. And we're going to connect. Before you connect, verify that IP address. Hardware configuration compares the online startup configuration with the offline configuration. If there's even the slightest difference, you'll see this window, which highlights the differences in red. So, which configuration do you choose? The offline on the left or the online on the right? It depends on which configuration is correct. If the project configuration is correct, then you choose the left side, use offline configuration. But if the controller configuration is correct, or you're just not so sure about your project, you would choose use startup configuration to keep the controller unchanged. And here it's pretty obvious that there are many differences between offline and online, but sometimes it's not so easy to tell by this window. If the difference is in a servo axis parameter, you can right-click on that axis and choose Show Differences. And this may help you determine what's on the offline project and what's actually in the servo itself. And could give you clues so that you can decide which configuration to choose. Close. The good news is, whatever you decide, it won't be too late to change your mind because it's not permanent until you save. So how about we choose the startup configuration on the controller first? Now we're looking at the configuration on the controller. Notice the devices we added. Well, we have the servo axes, but this axis 5 is different, and the option base that we added is no longer there. Can this be undone? Yes. All you need to do is first disconnect, and now you're offline, but showing still the previously loaded online configuration. Since we didn't save anything, you can close hardware configuration, don't save, and now open it again, and this will reload the offline configuration. Now we're back to what we had before. This time, let's connect, and when we're presented with this window, let's choose offline this time. It's important to notice it says writing drive PNs. This means that any amplifier parameters that can take immediate effect will do so. But all the settings are at this point still temporary because we haven't saved. Also, you can see that devices which we don't physically have appear still in the configuration as offline. For example, this option base, which we don't have on our controller, is part of the configuration, but it's not there, so it's offline, and we could add it in the future. If you choose the offline configuration and want to change your mind and go back to what the controller had before, it is pretty easy to recover. You just have to reboot the controller. So reboot the controller, and then those parameters that were sent to the amplifier will revert back to their saved values. Reboot, and yes. And then in the meantime, I usually close the hardware configuration. We're back online with the original parameters back into the amplifiers. The point here is that no configuration is permanently saved to the project, to the controller, or to the amplifiers, regardless of whether you choose online or offline. As we've seen, choosing online simply loads that data into the hardware configuration screen. And choosing offline simply sends the data to the controller and servo temporary memory. If the system is rebooted, it will revert back. Let's launch hardware configuration again. If we connect again, we are still presented with the same screen, so everything's back to how it was. So this is a pretty good safeguard, and the conclusion is that the user must take action to save while online before the data is permanently saved. Online save makes the controller configuration permanent, the servo parameters permanent, any variables and I/O drivers, everything is made permanent when you save online in the hardware configuration. When you save online, both the offline and the online configuration will now match, and you will not be presented with the configuration comparison window. Thirdly, the changes to the system don't take effect until after reboot. They're permanently saved, but they don't take effect until you reboot the system. So let's get a project we can trust and save it online to the controller. The project we'll use is part of the class materials download called hardware config. Say goodbye to project HC and close this configuration comparison window and exit the hardware configuration. And will you please go to File, Open, Unzip, and navigate to your class materials location, and please unzip the hardware config project. Now it's asking if you want to unzip to that same folder. In my case, it's on the desktop, and I do not want to. Let's save to our projects folder. You click No, and then you can navigate to see users public documents, MotionWorks IEC3 Pro projects, and save the unzipped version of the project here. If you get an overwrite message, you can click Yes to all. This project doesn't really have any code to run. We're just going to look at the hardware configuration. And it has a default configuration for each of the servo axes. And I have enabled the Modbus slave functionality just so that this remote I/O can talk to the controller. The remote I/O will not have any function except for the lower portion that communicates to the VIPA module. And now please adjust your IP address and connect to your controller. And we want to load this project onto the controller. So which side should we choose? We should choose the offline configuration to send from our project to this controller. This is a known good project that we provided for you. So use offline configuration. And now we are online. Is the configuration we see here permanent yet? No, it is not. You need to click the Save button for an online save. Now the hardware configuration we see here is permanently saved, but as the message says, the machine must be power cycled, meaning reboot, before changes take effect. Let's click OK, and under the online menu, there is a shortcut here to reboot the controller. Let's use that. When that reboot completes, now you can go back to hardware configuration and connect. And this time we were able to connect without any configuration differences because there are none. This is the normal usage. You don't typically see configuration differences between offline and online during your project development. You are likely in this case to see an alarm on axis 5, that's why it's red, Why don't we get rid of that by clicking on Axis 5, go over to the Alarm tab, and it says ACC0 multi-turn limit disagreement related to the encoder. Hopefully you remember that this encoder alarm can be cleared in the web UI, but it can also be cleared here with this blue button called Reset Absolute Encoder. Let's click that. We will need a power cycle. No surprise there. Okay. It says we're ready for the power cycle. Let's click OK and reboot here one more time. Reboot controller. So there the controller reboots the drives and the ACC0 is gone. On the left, our dual axis drive is complaining about P and N, which means positive overtravel and negative overtravel inputs are not connected. And we'll take care of that with some parameter settings in the next video. Let's go back to MotionWorks IEC, and as a little bonus here to hardware configuration, let's have you scroll down to the bottom left where it says global variables here in the physical hardware tree, global variables. Double click to open that. One thing that the hardware configuration does here is to create all of these axis variables. It's axis 4, axis 3, all of these variables are created because those axes exist in the hardware configuration. It also sets up the I/O configuration, which are the drivers to write to these variables to the correct addresses. This may be familiar to you if you've already taken the IEC Basics training, and if not, you'll find out more when you do. The point is, it's often necessary to compile and download your project again after saving a change in the hardware configuration. Okay, we've gone online and offline a few times and saved online, but what about a more serious scenario than this demo setup? I'd like to go through a few scenarios now. For example, this first one, you started a blank project and are connecting to a machine in production. Should you choose offline on the left or the online startup configuration on the right? You should choose the right, what's on the controller. You don't want to send that offline blank configuration to the controller. If you want to leave the controller alone, use the startup configuration. Number 2, you are deploying a new controller, which is at factory default settings. Would you choose what's on the controller, or would you choose the offline configuration? For this one, I think it depends on the project. If you assume that your project is already created and correct, then you would choose the offline configuration and send that configuration to this factory default controller. But if it's a brand new project and you're starting it for the first time, you might rather use the auto-discovered configuration that's on the controller as your starting point for building the configuration itself. It really depends on the project which configuration is correct. Here's a third scenario. The customer wants to add axes. So you opened the project and configured the new axes at the office, off-site. Now you go back to the customer site. You connect to the controller and you see that there are configuration differences. Do you choose offline or online? I hope you're thinking offline. Since you prepared the offline configuration, it goes to reason that it is correct. And the whole purpose of you connecting was to send it to the controller. Number 4, hope these are getting easier. You're not sure if your project is the right version of what's on the machine, offline or online. If you're not sure about your project, don't use the offline configuration. Keep what's on the controller and see what the differences are. Number 5, tuning. You just finished tuning the servos with SigmaWin Plus. This goes through the USB port of the servos currently. And many servo pack parameters have been changed as a result. So now you have connected to the hardware configuration and it's showing those differences on the controller. Would you choose offline or online? Definitely in this case, you would choose online. You would want to pull that configuration that's currently live on the controller system into your project and save it so that it becomes part of the offline project. Scenario 6, the machine is not working the same as it was before. You're sure you have opened the correct project and configuration, and now you see that there are some configuration differences. Which one do you choose? If you're sure about the project, choose the offline configuration. Especially if the machine is not working like it was before. It's possible that somebody perhaps tuned the servos or changed a parameter unintentionally. And finally, scenario 7, you started a blank project and you will set the controller to factory default. You go online and you get the configuration differences. Do you choose offline or online? In this case, the project is blank, so you really don't want that configuration. But the controller's configuration is not valid because you're going to set it to default anyway. So what do you choose in this case? The answer is it really doesn't matter. You can choose any of the two configurations you want. If you're going to set the controller to factory default, whatever configuration you choose will be erased anyway. In fact, to set the controller to factory default, you don't even go online in the first place other than to test your connection. Instead, you go to the online menu, Controller Configuration Utilities, and the second option down is Restore Controller to Factory Defaults and Reboot. I'm not going to do that right now, but that option only sets the controller resource to factory default, does not set the servo axes. You would have to connect to the servo axes and go online and set those to factory default one by one. And you can also reset the absolute encoders like we did to Axis 5. The factory default procedure is part of the quick reference guide, and we have a couple e-learning videos demonstrating how to do this. So if you're interested in the details, you're welcome to test this out on our demo. So please take all the time you want to play around with the offline configuration and online configuration. And when you're done, I suggest that you once again open that original ZWT project called hardware config, unzip it again, and then send that configuration again to the controller so that you'll be ready for the next section where we will set up the servo axes. Thank you for watching this video, and remember yaskawa.com/IEC for more information on the MPiec product line.